We will now begin the panel discussion on field experiment and RRI, responsible research and innovation for weather control. First, I will introduce the panelists from right to left. Okay, so the Billy Williams, Executive Vice President for Ethic and Organizational Advancement, AGU, USA. And second is Sarah Tessendorf, and Project Scientist, NK, US. And Stephen Siems, Professor, Monash University, Australia. And then finally, Dr. Takemasa MIYOSHI, Program Director of Moonshot 8. Okay, I am Moderator, Tetsuo NAKAZAWA, or Sub-Program Director of Moonshot 8. And also, we have 55 minutes, and first half I take care, and the second half, SHINEHA sensei will take care of for LC component. So first half, I take care of science part. For the science part, I will discuss 3 themes. And first one is ongoing for MS8 project. Maybe everyone already knew what it is. And I would like to get your comments for the projects, okay? But I think maybe the first and second is closely related, and the second one is current and future directions on weather controllability in MS8 or in general. So maybe it's better to change. First, I would like to hear about the current and future directions on weather controllability. And then second, maybe you may extend ongoing MS8 project. Okay. So first, maybe the second one. How do you think about the current and future directions on weather controllability, including not only MS8 but also in general directions? Okay. Is there any comment? Anyone who would like to say? Oh, Dr. Siems? Okay. Yeah, thank you.
I guess one comment that's come to me is, at this stage, there's a lot of numerical simulations. The uncertainty hasn't really been quantified for what I have seen. And I think this is an essential component, that we have to appreciate the uncertainty in some of these physical responses, and so that we can measure risk, or we can somehow assess risk. I mean, this was a fundamental part of what Billy said earlier today, was learning about risk and communicating risk to the public. So I see this as a very important step for us going forward.
Okay, thank you. Any other comments?
I will say, I mean, repeating something I said earlier, as I listened to the presentations yesterday and today, there was a heavy technical emphasis yesterday, but it was clear that even in each and every presentation, there was always a discussion around the potential impacts and societal implications, which I thought was very positive, that the whole program had been organized with those themes in mind. And even the speaker this afternoon just talked about having the various LC panels come together as well. So it was refreshing and reassuring to see this. Clearly you're doing things that have societal impact in terms of impacting heavy rain and typhoons on here in your local environment. So I think it's been a very thoughtful job in putting the program together. So my point of view is not so much from the technical content, but how it's designed and how it's being managed and governed. So thank you.
Okay, thank you very much. Oh, Sarah?
Yeah, I'm gonna add on to what Steve said too with the uncertainties. I think it's really important that the signals that are being seen in the sensitivity studies, one, encompass perhaps an even broader set of parameters than what's currently been done. There's a lot of progress that's been made, but in several of the projects, I could think of a few other parameters that should maybe be looked at for sensitivities. And in doing so, understanding if the uncertainty in the model, if the signal that's being simulated is actually greater or less than that overall uncertainty in our ability to model these different processes, that's going to be still really important to quantify.
Yeah, thank you. And as MIYOSHI-san said, with small power, so then we would like to get a big change. So then, in that sense, we need some breakthrough to do that. And maybe we still have a long way to go, but we need to find out a sort of new technique or new finding to do it. So, Miyo-sensei, do you say some few words?
Yeah, well, certainly the model is imperfect, particularly if you think about the intervention, human interventions in the model. So far, the project investigated the response of the model if we, for example, do the seeding operations in the model. But what has been represented in the model is not really seeding operations. It's some approximation or some expected results from seeding in the model variables. And it's not clear what actually happens in the real nature. If we, for example, put some materials in the sky and how these materials act in the sky, in the turbulent situations, and they move around, and how they act in the real case may not be well represented in the model. So that's why I'm very happy to see that Kotsuki project is now ready to do the actual seeding operations. And it's really essential to make the intercomparison with the model with and without seeding. And we cannot do, if we do in the real world seeding, we cannot see what would happen without seeding. But still, I think that if we design the experiment carefully, we will be able to evaluate to some extent how the model performs. And also, it's really essential to keep developing the fundamental processes in the model so that we can represent the seeding, for example, the seeding operations in more precise way in the model to reduce the model imperfections. And not only just seeding, but also, for example, Yamaguchi project. Today, Yamaguchi-san presented the windmill, the turbine. And that's also not simple, because if we think about the scale of those turbulent motions associated with the turbines, it's very difficult to represent very precisely those turbulent motion and how really the weather interact with those turbines. So there is some scale gap between the model to investigate the turbines and to investigate the weather. So that's fundamental disconnect at this moment, so that we need to have some uniform platform or the software to investigate the intervention scale to the weather scale. I think the model development is still very important, and together with the actual field experiments.
Yeah, I think so, especially to synchronize the intervention with model output. So still we have a large gap in between. So that's why we have to fill the gap. Any comment?
Yeah, I want to add to that too, because I think the field studies are really important so we can constrain the models, have some way to evaluate the models. But one of the other challenges is knowing exactly what observations we need when we do a field experiment. And so in the cloud seeding research that I've done, and we run the model simulations, some storms we get really big impacts and some we get very small impacts. And it's still ongoing research to try to figure out what are the factors that control whether or not we're going to have the potential big impact or small impact. And if we want to even measure that impact then too, we're trying to see, can we detect the impact, but we also probably need to do a better job measuring and observing whatever properties of the atmosphere control whether the storm will be able to be one of those big versus small impact storms. And so I think that some of the observations we need don't really exist either. So I think that's another thing as this program moves more into the field observation phase, is thinking about, we know we have radars, we know we have microwave radiometers for, we have certain instruments, but are there instruments that we need if we're going to actually do a better job of detecting the impacts or being able to predict which storms are going to be the best ones to target for the trials?
Yeah, very important point. Yeah, because we have to make a first observation, and then we can run the model, then we can get the impact or whether it's worthwhile to intervene or not, and then we can decide. So it's a really long way, so many processes. Yeah, and that's different from weather modification. Weather modification word, I feel that just something we do. But the control is we intervene towards anticipated directions. We already have some sort of target result by running the simulation. So then we would like to make an intervene towards a direction. So that's maybe some difference between control and modification. That's my understanding. Anyway, we discussed a lot. So maybe we move on another issues or comments, if you may have. Yes?
I think when you go out in the field, it's going to be a very, very exciting development. I think this is something that would be greatly anticipated. As Sarah mentioned, this is a critical step for evaluating the simulations. The simulations, as MIYOSHI mentioned, you're going to be developing the microphysics, you're going to be developing the dynamics, you're going to be changing the scales, looking at the initialization, all of these things. Until you get out in the field, this is really when you start making some developments. So it's an exciting phase coming up.
Dr. Sara, do you give me a comment on model development, especially microphysics, in the your field experiment?
Did you give a comment on what aspect of the
Model development, especially
model development?
microphysics.
Yeah, no, and the posters yesterday, I saw some of the work that Shinichi Hiroshima has been doing with the super droplet method. That's one of the big developments in the microphysics modeling world. It's really intriguing when you can see simulations of clouds that look like the clouds that we see. And so that's one of the nice developments, but they're very expensive simulations to run. Yeah. And so it's got a lot of promise, but we still need to use a lot of supercomputing time to be able to simulate with those. And they are not going to be able to run fast. So they're not going to be able to run in that form in the way that you described. That would be, we're trying to decide, should we intervene? Let's run a simulation really quick and see what the result would be. But because there's such detailed and improved representations of the microphysics, they can be used as maybe training for some AI models that could maybe run quicker, because that's how sophisticated they are. They're simulating all of these different particles and their trajectories in the Lagrangian framework, which is quite novel. So that's one major development, and it's great to see the updates that I saw in the posters last night there.
Yeah, thank you very much. I heard the next Fugaku is coming. So then Shima-san said it's getting much faster. And also AI-based new algorithm should be developed. Yeah. How about Stephen? You may have also comment on the modeling stuff, or
I'm not as experienced in the microphysics development, but I guess looking at some of the work with using direct numerical simulations to inform large eddy simulations and using AI from there, it's still very important for AI to have lots of observations, lots of realizations under very different circumstances. It's you know, one direct numerical simulation is not going to develop a robust parameterization of turbulence. So, and then as Sarah mentioned, observations are really going to be essential in verifying some of these processes when you bring it into the microphysics. So it's great to see the advances we make, and we are making advances so quickly, but there are some huge hurdles still ahead of us.
Okay, thank you. And then maybe we would like to discuss the current ongoing projects, and 2 for typhoons, another 2 for heavy precipitation projects. So maybe you learned a little bit difficult for typhoon control rather than heavy precipitation events. And how do you think? How do you feel we are challenging, tackling these issues to solve in 2050, and we still 25 years we have. Okay.
Okay. Good. So the typhoon is very well organized system, and when it develops, it develops. So it's something very difficult to change, because the small perturbation will decay most of the time. So we need to find what perturbation can really make change. And if we think about a single convective storm, it's much more chaotic, and that means that it's easy to change, but we cannot predict how it will change. So we have a theory that we can control that kind of situation, so that even if we cannot predict, because it's beyond predictability based on chaos, we have a theory that we can track and keep track and control in the desired direction. That's possible. But typhoon is different. But if we make the ensemble prediction for typhoons, the small is different because the typhoon is big. Small is already big, maybe. But small perturbations in the initial conditions can grow, make significant difference for some cases, not always, because some typhoons are very stable, so that perturbations may not grow as fast, but some cases have a big growth of the perturbations. And that kind of case may have a chance. And as Sawada-san showed yesterday, just manipulating, the development of a single convective cell within a big structure, very well structured typhoon, can make significant difference in the whole structure. So I saw that Kotsuki project and the Yamaguchi project focuses on relatively small scale convective storms, like a single convective cell or some organized convective cells, but it's like a countable number of convective cells. And if you have methods to develop for controlling those single convective cells, that may have a chance that we could apply that method in convective cells within Typhoon. That can lead to the Typhoon scale. That may be a path, still not clear to me, but directly trying to change the Typhoon itself seems to be very difficult because it's too big. That's my current understanding.
I watched yesterday's posters and presented by Tsuboki Sensei, and there is a chance to also weaken the Typhoon by seeding. And in numerical simulations, we are not sure in the real world what happens, but still, I suppose there is a way to weaken the Typhoon. Currently, still experimental stage, and we would like, maybe Tsuboki-san is seeking the mechanisms why we can get such kind of tendency, but maybe he's extensively working for it. It may take time, right? Tsuboki-sensei is here? No? Okay. Anyway, time runs so quickly, so maybe I cannot discuss a field experiment, but maybe that's also related with LC issue. So maybe SHINEHA sensei will discuss this issue. Okay, so thank you very much.
Thank you very much. My name is Ryuma SHINEHA from Keio University and one of the advisors of the Moonshot Goal 8. And my expertise in social science and science policy, and their advisor on the LC matters on this program. And I would like to continue to discuss about this project, how to conduct a social implementation to the society of our Moonshot Goal 8 insight and their achievement. So, and I set 3 questions. So first is the LC is, what kind of social systems will we require to implement the weather control technology to the society? So, and I think this question can be paraphrased to the what is conditions of trustworthy weather control tech. So, and firstly, I would like to start from this question so that please, I would like to ask you all so that what is your idea about the conditions for the trustworthy weather control technology. So, and I think this question maybe that's deeply related to the AGU guidelines, right? So that I'd like to start from asking you that Dr. Williams. So.
This is very interesting to me, and because I see parallels between this work and the bigger climate geoengineering work, and one is how you gain that public trust around the terms you use. And I know I was challenged today, and I admitted that we had tended to use in AGU the word climate intervention rather than climate geoengineering, just because of the perceptions around the terms. But I also heard today that the word we're using here is weather control as opposed to modification. And I think we should consider what do you want to, how strongly, the speaker this afternoon talked about that, how strongly you want to use the word control in this space as opposed to modification or intervention or whatever, because the average, this might be something you're testing in the public. I think when you do your public outreach and focus groups, maybe test those words. Test how they respond to control versus modification. Because a lot of this, as you plan outdoor experiments, that's the public is going to be responding based on their own biases and perceptions. And sometimes when scientists are involved, especially I'm a scientist by training as well, we have a reputation for doing things aggressively in a way that the public might not be comfortable with because they don't understand it. And when we say we're going to control the climate or control weather, then you're getting into tricky territory. So that's my comment. I'll just put this out for consideration. Thanks.
Thank you very much. So, and we maybe then now understand that we need to reorganize the concept of the modification, intervention, and control, and so on, and it will bring that the different imaginaries about the technology that we would like to implement to the society, right? Okay, that's Dr. Sarah. Do you have any comments?
Yeah, for the conditions for trustworthy weather control technology, I think this ties in with the RRI principles as well that you've drafted and put together, but, and this is also something that in the US, when there's weather modification, the programs follow this, but having clear guidelines for when you would not do the intervention or not do the modification, we refer to those as suspension criteria for a cloud seeding program. And those are important to be defined with stakeholder engagement as well. I mean, there are some basic ones as meteorologists and weather forecasters that we can think of that, you know, we don't want to produce too much snow if it could flood later. There's, you know, the ones that were mentioned earlier on the field program that's getting ready to happen this January, that if there's an active winter storm, you know, we wouldn't want to manipulate that. But the other things might come up from stakeholder engagement that we wouldn't think about. And an example in the US was an agency from the Department of Transportation was concerned that some of the cloud seeding would lead to more snow on an interstate highway where they have to do snow plowing, and they didn't want that. And so they asked that under certain wind conditions, don't use the cloud seeding in that part of the region. So that's just an example of when you engage with a variety of stakeholders, you might have some additional criteria to follow. In addition to defining those suspension criteria, the other aspect is what things need to be monitored so people feel safe, like what you're doing is safe. And monitoring is really important, and it's been also mentioned in the principle, the RI principles, but what are we monitoring for? We could monitor for a lot of things, so that has to be better defined. And again, stakeholder engagement is really important there so that the things that are being monitored help make the residents and the people involved feel safe.
Thank you very much. So how about your ideas, Dr. Stevens? Do you have any comments to this?
Your question again?
And what is the conditions for the trustworthy weather control technology in the society? So.
Well, that's an excellent question. I really don't know if I can answer what is trustworthy. Many years within weather modification, and I think that is still a very vague term, and it depends on who is asked about it. But I think the best we can do is to be as communicative, honest, engage people. I think trustworthiness isn't going to necessarily be done on a scientific level for many people. It needs to be done on an emotional level. I think in this world nowadays, unfortunately, science only gets you so far. Communication, engaging is very important for establishing trust. So it's hard for me as a scientist. Sometimes I'd rather just sit behind a desk and look at the data and look at the satellite photos and that, but we need to establish good communication. So yeah, that's best I can say.
Thank you very much. And to doctors and emphasize the importance of the engagement, stakeholder engagement, public engagement, and this will be can be connected to their discussion about how we conduct our deep communication with the society and the various stakeholders. And the Moonshot Goal 8 also that conducted so many stakeholder engagement and the public communication activities. So that I would like to ask the Dr. MIYOSHI Sensei, so how to design the communication with the society here after all the Moonshot Goal 8, so that we need much more communication with the society, right? And do you have any ideas and directions of the communication with the society? So.
Well, so Kotsuki project already plans the field experiment in January, and they already started this, some meetings with the local people or the local governments and various stakeholders. So this is very important to have opportunities so that people to interact with the people, and we need to directly communicate with the people what are their concerns or expectations, let's say, because this is a national research program, and what we do is to build a bright future. So we have a hope to develop this new technology that's good for the society or human being even. But at the same time, we may have some risks, and the local people may not feel comfortable by being chosen to be the location of the initial test, because it's similar to other things like nuclear technologies. Some places need to be used for that, but so it's very essential to have a lot of communication opportunities. And yeah.
Thank you. Please, Dr. Sara.
I wanted to bring up the role of social media, because like you said, the previous presentation showed a lot of community engagement through different meetings, and I think that's really important, especially because you can have a two-way communication when you get to meet people in person. Social media, on the other hand, is growing in popularity. It's growing in as the method for how people get information, for better or for worse. And I think you brought this up in your presentation too, that there is a role for it, but I'm curious, and I almost want to ask others about this too. What is the role for it? Because personally, I prefer the opportunities where there can be that two-way dialogue, because if I were to just put out a video on YouTube or whatever social media platform about what I'm doing, you get all the people commenting, and some of them are mean, but I don't get a chance to answer their questions or clarify or ask them more about the root cause of their concern. And so I think there's a role for it, but personally, I want to put my energy into the in-person dialogue, but then finding the right meetings and venues to get people to attend is the challenge. You reach a bigger audience on social media, but is that beneficial? And I don't know, maybe Dr. Williams has some thoughts.
Yeah, that's a great point, Sarah. And some consideration is around finding trusted figures to carry a message. It could be somebody already in the public, could be an actor or entertainer even, but someone from a different space that you would not normally communicate through could be considered for usage if there's a high-profile person in any of the communities that you can use that will want to carry the message because they know and trust that what you're doing is for the benefit of society. Having them being a spokesperson through social media even could help amplify and get the trust you need. If I'm out there telling your local community, do this because it's good, let's go for it, they're not going to believe me. They have no reason to trust me, but they trust people that they admire. And I think finding those potential folks, even for your projects you're considering for outdoor experiments, especially when you get to a point where you consider something of some significance, durability, or scale, then perhaps consider having some spokespersons help carry that message is one thing to consider. And that message could be carried through social media as well by them. Thanks.
Thank you very much. And during this discussion, we also learned about already that Kotsuki-sensei's project around the conducting such kind of dialogue with the local government and local people. And however, at the same time, we need to think about how to relay our lesson to the younger generations and the younger scholars, so that so I think that Kotsuki-sensei have a duty to educate the younger generation to about your project lessons and their accumulation of the knowledge to with the stakeholder engagement to this project already as a leading project of the public engagement on this matter. So I think so. Anyway, so and. Finally, that I would like to ask one serious question. So that you know that climate technology and weather modification and weather control technology, the coincide with the dual-use matters. So and sometimes it brings some serious concerns about the security matters and in some time, maybe that invasions is a nationwide something. So, and how to think and how should we consider this serious matter of the weather control technology and how to prevent? However, that it can be perfect as the nature of the discussion is about how to prevent the harmful effect of the weather control tech to the human beings and the environment, animals, and the society. So that how to do, and do you have any ideas about this point? So and how to prevent such kind of harmful effect of the weather control technologies. So sorry, this may be the big point. Anyway, so and please teach your ideas about on this matter. So. Okay, Dr.
I would say the best way to keep the harmful effects limited is to be as transparent as possible. You know, this is a good way of establishing what you are doing, what you are trying to do. I mean, it sounds simple, it sounds straightforward, but I think it's still going to be a lot of work, but I think that's the best we can do.
Yeah, thank you very much.
I referenced a few experiments in the U.S. that were shut down completely after a lot of investment. And the amount of materials they were putting into the atmosphere were minuscule. It would not have likely caused significant harm to anybody or any species. But the fact that they were not transparent, the fact that it was being done sort of without disclosure, behind closed doors or whatever, caused a big public outroar. And for a group of folks called Make Sunsets, when they did their balloons in Mexico, the Mexican government passed regulations or made an edict that we will not support geoengineering research in our country. I think that's changed a little bit, but that's the type of reaction you get when you're not transparent. And Steve, just to reinforce what you were saying, that transparency builds the public trust. It doesn't answer the question about preventing harmful human effects, but that's why the public is concerned in most cases, because they don't know, and you haven't been transparent. You must be hiding something if you're not telling us what it is you're doing, or what do you know if you put in particles in the air, what are the health effects of those particles. And so I think having the research, the background, the research data to show that you've already studied and understand what health effect might be or not be concerning the particles you're using, so explain it as part of it. But if you are, I don't want to say there's no reason to not disclose, but if people aren't disclosing, to me, it causes suspicion off the bat, whether there's harmful effects or not. You have to be transparent with what you're doing and the reason you're doing it.
Thank you very much. So, and the transparency and the disclosure of information is the key factor to the to face to the serious matters on this point. So, and I think this point will also relate to the how we can cultivate the trust with the society and trust with the public. So, and thank you very much for your key insight about on this matter. So, and sorry that for my failure to the time management, only 2 or 3 minutes remains on this session. So that I would like to open to the floor to the discussion. So that do you have any questions? Maybe that we can take 1 or 2 questions. So that do you have any comment or questions? So on this, there are social matters and policy directions. Okay, that Kotsuki-sensei, please.
So as Yasunaga Sensei presented, so we are planning to employ the field experiment this winter. Okay, yeah, and but what we are worrying the most is misinformation. So and while we haven't discussed on that point, but sometimes once the like disaster happens, some people say that it may be due to some experiment, and so we need to address such concerns carefully, but so like enhancing the transparency requires opening more information from our project, and we would like to be transparent as much as possible. But we are also thinking that would accompany the increased possibility of such misinformation. And so this year we will do the seeding very, we seed just a slight amount, but for subsequent years, so we need to, how to say, enlarge the experimental, how to say, scale. And at this moment we do not have good answer how to face to such misinformation situation. And I think it happens not only for weather control, but also for any kinds of research activities. And if there is a good solution or some good ways to think about, so I would like you to share how should we face to such misinformation. As Sarah mentioned, maybe one-way communication is pretty sometimes dangerous, but we need to carefully thinking about it. Yeah, I just share our concerns, the most concerns.
Okay, thank you very much. Yes, please.
It's a very legitimate concern. I don't have an answer for that. I think the acknowledgement and awareness of that is important for all of us, but I don't know what others have answers, but I think, Steve, you and I talked about that a bit yesterday in terms of misinformation and how some individuals tend to misinterpret things and put it out there in the public deliberately when it's not true, when they know it's not true. Anyway.
I think Sarah can mention this too. It can be quite time consuming. I work on this expert team on weather modification, and anytime there's a flood, almost anywhere, we're asked, was it weather modification? Was it some government weather modification, whether it's in Spain or China or Australia or Texas in the United States? And sometimes you get engaged in very long conversations and trying to explain this. I don't have a good answer for this. It would be nice if we hired an expert, but they want to talk to us as the experts. Sarah, I don't know if you have better luck with this than I do.
No, and that's also why I brought up the social media topic, because it can be, it's full of misinformation on the social media. And so on one hand, it's like maybe we need to make sure there's more appropriate information than misinformation on social media. But I personally think people that are spreading misinformation have way too much time on their hands, and they're going to, I don't know what they do, but spend a lot of time on that. Okay. I was thinking, though, with the idea of transparency, I think that with some of the cloud seeding programs in the U.S., they've been talking about whether they should have a website where they say when they're actually seeding versus not, like a red light or a green light, something to indicate when it's happening versus not, because then if somebody wants to know, they can find out at any time. Right now, it's harder to find out when cloud seeding was done because the only reporting that's required is at the end of the winter. So it's way after the fact. Is that going to help with misinformation? No, because if somebody wants to say or attribute anything that they don't like to cloud seeding or to the treatment, they'll go on the website and say, see, it was cloud seeding. But maybe we also need to not just say yes or no, but confine an area of impact, or I don't know, just more information like that that's available in real time could help with some people's concerns. But if somebody really wants to spread misinformation, they take a grain of truth and then they create a narrative around it in whatever agenda that they have. And I don't know how we stop that, because the social media train has left the station in that regard.
Having the real-time monitoring, like a system on the web or something, is very useful. So we will try to develop it. Thank you very much.
Thank you very much. And unfortunately, the time is out. So, and thank you very much for the participants and panel speakers. Thank you very much. With please big hands.